Hi, I'd like to describe the construction of a fascinating 8-note scale I just discovered. What I really find interesting about this scale is that it contains the irrational numbers pi and phi, both of them. It's made up of two symmetric parts. So in that sense, it could be kind of likened to tetrachords, but this is quite a bit different. I'll start by saying we can sort of consider it an extension of the pentatonic scale in one way. I say that because here's how we could imagine constructing the pentatonic scale. Go up, so I'll start on G and we'll go up the purest interval, the octave, and we'll go down the next purest, perfect fifth, then go up a perfect fourth. So we'll just do that with the perfect intervals. Now, let's do the same in reverse. So we start by descending an octave from G. We go up a perfect fifth, and then down a perfect fourth. Now if we put these two sets of notes together, we get the pentatonic scale. Okay. So what if we continued this process out and we didn't just stop with the perfect intervals? If we went then major third, minor third, and continued doing this ad infinitum, we would eventually come to the limit pi divided by 2, somewhere in here, but not quite. Okay, so I'll just show that here. So if we go up an octave, down a perfect fifth, up a perfect fourth, down a major third, up a minor third, and we continued this on ad infinitum, we'd come to pi divided by 2. Okay, very good. We can imagine, what if we want these two processes when we ascend and onto this? What about when we descend? What if we wanted to eventually reach the same note? How would we do that? Well, it turns out that we need to separate these two approaches by essentially phi, actually 2 over phi, so 2 times the inverse golden ratio. And so we have the ratios pi over 2 and 2 over phi. So we have both of the most famous irrational numbers in the scale. And why do I say an 8-note scale? Because at a certain point, these intervals become so small that they're almost like debris in the field of a planet. So our planet is the limit, pi over 2. And the only other notes that I add are the perfect intervals. So it has a really nice sound in a way. Xenakis had a construction of a Byzantine liturgical scale that's kind of similar in that it had some nice harmonic intervals, and then it had pi over 2, although I'm not sure he knew that that interval was in there. But anyway, in 72 EDO, the degrees are 0, 22, 30, 34, 47, 60, 64, 72, and 94. So this scale is in kind of like 72 EDO, but it doesn't use the octave. It uses 94 steps as its period. Actually, since this is a symmetric scale, we can overlap the first and the last intervals and fit the whole thing into an octave, of course, And then it becomes a 7-note scale, so I lied earlier about it being an 8-note scale, I guess, unless you just like a non-octave 8-note scale. Okay, thank you for listening.